All right. Sorry about the delay, folks. I couldn't get OBS to render my text editor or to capture my text editor for some reason. But appears to be working. Let me know if there's any problems that I might need to look at. I see a lot of activity in the thread already, which is great. We got a question here. So let me go through this. One second, let me just pull this up and we'll take a look. Okay, yeah. Apologies. I'm gonna take this. I can take this question if you want to meet after stream. The person asking this first question on Cartesian factorial. We can go through this after stream if you want to do that. Just DM me and we can work that out afterwards. I do want to keep the questions local to the Python material for now. So apologies for the inconvenience. All right, I'm going to move on to the next one for now. This is regarding, we have a few here. Okay, write a function called isNumber. Okay. String properties. Cool. Okay, isNumber. All right, looks like we have some prior solutions to this floating around. I'll just push those down for the time being. All right. So let's pull in the problem statement and I'll go over this. So write a function called isNumber, blah, blah, blah. All right. So these are our tests, it looks like. So let's do this. I'm just going to turn these into tests and we'll go from here. Cool. Write a function called isNumber, takes in a string as an argument and returns the type as a string if the string is indeed a number. And the string is not a number, or not a number otherwise. So we'll return this if it's not a number. Cool, so this is what we should get for float. Let's do one for int. I'll just do 31. Okay, cool. So we'll do a little basic type checking in this, and we'll also do a little work to verify the that a float is a float, right? Because here's an example of some code that might give us a float, but shouldn't be considered a float because it has more than one dot in it. Okay. So let's see here. Let's read the notes. If the string is a number, its type is either int or float. You will need to account for numbers with decimal points in them. And empty strings should be considered not a number, which I'll just handle that as an edge case right up front. So let's just take in our number. We'll call it n. Oops. And we'll say if n equals empty string, we'll return, what was it? N-O-T-A, no, not a number, with a capital N at the front. Since this is capitalized right here, just to be clear, the test in learn will fail if this is lowercase, if this is not exactly as that's typed right there. So that could cause an issue. So make sure that those strings are being returned exactly as specified. So int and float need to be uncapitalized as well. Okay. So we can tell if something's not a number if it has a character that's not a digit. So let's just go, I'm calling this in. It should really call this text because that's what it is. It's a string. So we'll call it text. And then I'll say, I can see if something's not a number by checking every character. So I can say for ch in text, if ch dot is digit, there's a method for strings that's called is digit. Is digit. And we want to know if it's not a digit, right? So we'll say if not ch is digit. So ch dot is digit will return true. Oh, wait. Yeah. Oh, I just realized I've solved this one a few times before, and I have this realization every time. Because I need to know if it's a digit or if it's a period. If it's a period, that still could be a valid that could still be a valid character for a number because floats contain periods. So an easier way to do this is actually just say if ch in, and I'm going to do a test for membership, and I'll do just number characters, and I'll do a period as well. So let me put that at the beginning. So period and 0 through 1. Okay, so if ch in this string, actually, and again, I want to say not in this string, then I'll return not a number. Same thing here. If we make it through that list or that loop without returning, then we can say if dot in text. So if there's a dot in it, then we'll return float. Else return int. And I need to account for there being multiple dots in the text. So let's just run this. We're going to get, I think the second test here is going to fail, where there's 2 dots. That'll give me float, and it should give me not a number. So I get float, float, int, and not a number, and the second one is failing. So I think I can just consider this, I'll just consider this an edge case and just check this right up front, I'll say if text equals empty string or text.count period is greater than or equal to, well, I'll just say greater than 1. So if there's more than one period in the text, then we'll just return not a number, and that should handle that other edge case. So float, not a number, int, and not a number. And that's what we expect. Cool. Let's check that. Good. And let me make sure I didn't have any other ones. Oh. It's going to run this one instead. I think this is exactly, yeah, this is exactly the same code though. So that's fine, whatever. I'll just run it so it actually checks on the code that I submitted here. Oops. And that's correct. Good. Okay. So I need, or excuse me, I see another question by the same asker. Letter IDX. Let me pull in this link. Cool. This is, oops. Okay, letter IDX. Here we go. This thing's always looking up things in the dictionary. I don't know how to make it stop. I should probably, there's probably some settings that I need to change, but I don't know. All right, cool. Write a function called letter IDX. That will track the indices of where the vowels occur in the string. Okay. Take a word or a sentence as an argument and return a dictionary with the keys representing the vowels and that occur and the values representing the indices where those vowels occur. Okay, cool. So hello there should give us this dictionary. Well, let's make this a test. Print def okay. So I see that it's returning a dictionary. So let's just make a dictionary and return it. I'm going to run it, but we're just going to get an empty dictionary, which is obviously what we expect. So let's populate that with the correct values, the correct items. So I have this text here that has all the characters in my, well, in my text, in the input, and I'll say for ch in text. Then we'll see if ch is a vowel. If ch in, I'll do the same thing I did before. If it's a if the character is a member of the string AEIOU, are we doing? Oh yeah, for this exercise, the letter Y is considered a vowel. Okay, so AEIOUY. So if it's a vowel, let's just print CH. Just make sure that that it'll run EOEE. So that's 3 E's and an O, and I expect 3 E's and an O. Good. Okay. So we've discerned that whether a character is a vowel or not. Okay, so now we need to, well, we also need the index of each vowel. So anytime you're looping through something and you're like, oh, I need the index, or anytime you have the thought that you need the index associated with the element, you probably need to run a for loop and enumerate. You need to run through enumerate the enumerated version of the object, and that'll give you the indices as well. So let's just print out IDX and just make sure that that's what we get. We should get 1, 8, 10, and 4. It'll be in a different order. So 1, 4, that 4 is for the O. 8 and 10, good, okay. So that's, everything's working there. All right, now we need to add the key and value pair. So the key is going to be CH, and the value will be a list containing all the indices. Okay. So now what I want to do is say if I want to add the key value pair in if it doesn't exist in the dictionary. And if it does exist, I want to append to the list at the value. Okay, so I'm going to check if it doesn't exist and add it in first. So I'll say, well, here, let me demonstrate why that's necessary first to take this step. Because if I try to say d sub ch dot append, I want to append IDX, I'm going to get an error, and it'll say, I think it'll say H is not, or it'll say key error H. Oh, E, excuse me, because E is the first one that I'm trying to append here. Right, so key error E. So what this is saying, and key errors in Python are unfortunately not very descriptive, or at least in this particular interpreter that I'm using, are not particularly descriptive, but you just need to know when you get a key error, it'll just tell you the key that it couldn't find in the dictionary. That's what that means, and you're just supposed to know in this case. So it says key error E, and we can just determine that that means E is not a key in the dictionary. So I do want to be doing this, but I have to have a list to append to. Append is not a method for anything else other than lists. So the idea is that d sub ch will refer to a list where I'll keep the indices. So I'll say I want to do this else. It's kind of backwards the way I'm doing this, honestly. We'll write the if ch not in d, then we want to d sub ch equals a, well, actually I'll do this without the else. So if ch is not a key in the dictionary, then we'll add it in, and since we can't have a key without a value, we need to give it the value that we want it to have, which is, we'll start it as an empty list, and then immediately append to it. So the real purpose of all this is really this line on line 46 here, where we're appending the index. But in order to do that safely, I have to check that that E or that character is a valid character in valid key in the dictionary. So line 43 and 44, lines 43 and 44, ensure that line 46 will actually run without an error. I'm just going to cinch this up because, you know, I don't know, I can. Cool. Let's run that, make sure it'll actually work. Oops. Okay, here's my previous solution. Oops. Okay, there we go. I'm just going to comment this one out. Put it in a string there. Okay, that one works. Cool. All right. We got another Python question here. Sep and sort. Here it is. Sep and sort. Cool, there we go. So write a function called sep and sort, takes in any number of unnamed parameters. Takes any number of unnamed parameters, okay. This function will take any number of integers and floating point numbers. It should go through all of the items that were passed, separate them by type, and sort each collection. Oh, interesting. The returned value should be a list of lists. Where the first nested list is for integers, the second nested list is for floating point numbers. If no values of specific types are passed, do not return empty lists for that type. Okay, remove it altogether. For example, okay. Cool. So we're going to get into star args, which is pretty cool because we'll see how you can write a function that takes any number of arguments. So this has, we can see we have 3 integers being passed here, and we get a list with a single list in it that has the 3 integers sorted from the lowest value to the highest value. And let's do another one where we have okay, we'll have these 3 floats in there, and let me just pop these in the input somewhere, kind of mix them in, and then we'll put these 2. Let's do this one at the very beginning, and we'll do this one right after that. Cool, okay, so we got a couple tests. So this is going to be interesting. So in order to write a function that can take in any number of inputs, where we would name the parameter, I'm going to start that name with star. So I'm going to say star, and by convention we just say args, star args. And this gives us, if I print args, now I don't have to call it star args, I just call it args, right? Its name is args, but the star says just keep accepting inputs and for this parameter called args. So let's just print out args real quick. So let's see what args is. That's the idea here. So we can see we have some output here. We have these two tuples and then none. The none is because this function doesn't have a return, but I'm printing it out in these tests here, so we can just ignore the none for now. And you can see that where I'm printing args, and why don't I be explicit about this? So you see where it says args because I just labeled it. So args gives me a tuple. So when you do star args, args is going to be a tuple by default. So, and we could just, well, I say by default, but what I mean is always. It's star args gives you a tuple. So to be clear here real quick, we don't have to call this args. It's just a convention. It's usually called args. That way, if you see a parameter called args in your code, you kind of have a sense that it's probably star args. You're using star args. But hopefully you also have a sense of that because you see that it's listed up here. So we could call this things or stuff or whatever. But I'm going to call it args. Okay. So let's just loop through this, and we'll say for element in args. We'll just print element and just demonstrate that we can just loop through this like any other tuple. Nothing fancy about it. It's just a regular old tuple. Cool. I'm actually just going to isolate this down to one test for now. We'll just comment out the second test that I wrote, and we'll just work on one. We have a little bit less confusing garbled output. So this is going to be an accumulator pattern. So I'm going to say list equals a list, and we're going to return this. And then here's the interesting thing. I'm going to say if type So it looks like I'm only, yeah. It looks like I'm only taking in integers and floats. I think that's the only thing that this needs to be concerned with. But I'm thinking of, my first impulse was to make a dictionary so I could have like the keys be type identifiers and the values be the lists of lists, and then go through there. But I think that's sort of out of the scope of what this problem is asking. So we'll do a simpler solution. I think we're only doing ints and floats. So we'll say if type L equals int, then we have to append to the int list, which has to be the first one. So maybe I could do you know what? Yeah, I'm just going to do this way. I'm just going to create the list with two empty lists in it. I wanted to do this kind of more dynamically, but we'll just do this, and if one of them's empty at the end of it, we'll just delete it, which is what this described up here, but yeah. You could make a more kind of dynamic solution to this, but for the sake of simplicity, I'm just going to bake these in, and we'll go from there. Okay, so if the type of L is an int, I want to append to the int list, so I'm going to say I want to append to this list. This inner list is a member of this outer list, and its location in that outer list is at index 0. So I can say list sub 0 is my int list, and I'll say dot append L, and we can do an lf type L equals float. Then we went to list sub 1 dot append. Cool. So that should get me pretty close. I'm going to have this empty list in this particular case here. So I need to find a way to remove that. I think what I'll do, I'm just going to say list 1 here, and then I'm going to reaccumulate from list 1 into list 2 equals empty list. And I'm actually going to return list 2, and we'll say for L, which I'm going to use as shorthand for list. So for L in list 1, if len L greater than 1, list 2 dot append L. Okay, so that should get rid of that empty list. Cool. So I'm trying to solve this in a very sort of straightforward way using just like simple additive accumulators, right? So if I look at both of these, let's just read this description real quick. Where did it say that? Said something about removed. Okay, yeah, so remove it all together. So we could take this approach where we're actually removing this second list from list 1, and we could look at an approach for that as well. But I just want to show that we can do this with simple like additive accumulators, which I think are sort of the easiest to approach. They're an easy, consistent way of solving a problem. So here I have my initial accumulator, and I could have done something like int list equals an empty list. Huh. Oh, I realize I like this better suddenly. Yeah, let's do this, actually. So I was going to say I could have done those two lists independently instead of nested in here, and it just occurred to me that I actually like that better. So we'll go through this and do it that way too. Float list, int list. Okay, so in this case, I'm just going to say we'll just build up int list, and we'll build up float list here, and we'll take away the subscripting parts there, and I think that'll do. And then now here, all I've got to do is float list, comma, int list. Oops, what am I doing? I'm going to do int list first. Int list. Okay, so now I have this tuple of these two lists, and we can just put them together right there. So I have these two different accumulators that are going to categorize each of the inputs into the appropriate list, and then append them as necessary. We'll just call that list. Cool. So that would be another take on this, right? And then I don't need that sort of list one, list two thing. This is another positive accumulator approach, right? So in any case, I'm just starting with empty things, running through a loop, and filling them up with only the correct things as much as I can, right? But you could definitely write more dynamic solutions to this. I really want to solve this with like a dictionary, so I can use the keys as type identifiers, and then have like a, so for every time I get a new type, I can append to the list at that dictionary. Ooh, I really want to solve it that way, but I think I will do that. I'll do that in a second here. Let's just test this, make sure it's actually gonna work as intended. Could do remove. Yeah, let's look at that as well. Ha, didn't even work. Okay. Well, let's see where I went wrong. Probably something really obvious that I missed. Oh, I didn't sort the output. Right. So I need to, well, append the sorted. That's what I forgot to do. Okay. Right. That was just like part of the problem that I just forgot. Okay. So we'll append the sorted version. Okay, good. That works. So we have somebody suggesting that we do del or remove. So there's a few ways we could do this. Let's do this list one, list two thing again. Okay, and then I have to remember sorted. Make sure this is going to work. So in this one, we could, if one of them is empty, we'll just remove it. So I'm going to go back to just calling this list. So I kind of hate numbering my lists like this. It's kind of, I don't know, it's just kind of annoying. Okay, so there's a pitfall. Here's one of the things, and I'm not saying you should never use like remove. When I'm talking about additive accumulators, I'm talking about I start with something that's more or less sort of empty or neutral, blank slate, and I'm filling it up. I'm adding things to it, right? And this tends to be an easy and robust way of working through problems. It's just a simple, consistent system that you can just kind of chug along and solve problems with when you have an additive accumulator. There are times to use subtractive or like reductive accumulators. I mean, it's kind of weird to call it a reductive and accumulator. Some people will call it a decrementation pattern instead of an accumulation pattern, where you're reducing the size of something. But to me, it all falls under the greater heading of a quote unquote accumulator pattern. So apologies if that's a little, that term is a little overloaded. It's doing a lot of work there. But so there are some additional pitfalls. There can be additional pitfalls to reducing the size of something in an accumulator. It's not so bad. It's manageable. I mean, there's times to do it, and it's good to know how to do. But I do want to emphasize the simple sort of additive style because it's simple. And for people who are just starting, you can get up and running with that. And yeah, like I said, it's a simple, consistent, robust way of solving problems. It'll get you there. So, but yeah, let's look at this removal approach as well. Okay, so I'm going to say so I don't need an accumulator, right? Because I don't need an accumulator target that's empty because I'm not doing that. So we'll just say for every list contained list in my list variable here, if the list has a length that's actually, now we need to reverse this. If it's less than 1, specifically we can say if it's equal to 0. So if the length of the list equals 0, then I can do del. So there's two things we can use del. We could use remove. I think we can use pop. Yeah, there's a few options we have, but we'll just look at del. So I want to delete this list, right? Actually, I think I can just delete L. Well, kind of. There is a problem with this code, and I'm trying to show this like this is an issue that you may face. Okay, so that didn't work at all. So let's do. Okay, so what I did is enumerate, and I'm deleting list sub IDX. So I'm getting the index of each nested list, and I'm deleting list sub IDX, and that'll delete the contents at that location. And this should give us an error. Oh my God, that doesn't. Oh wow. Okay. That's new. I'm used to using. I decided to use del here, and I assumed that this would actually give the same error. That's really interesting. Oh, I know why. Because I'm going through the enumerated list. So this is, I think, a de facto copy of the list. So enumerate sort of gives me that safety. I really wanted to show that error. Well, I know I know it can happen with remove, but evidently here's a valid solution for that works just fine. So yeah, I assumed that this would have the same behavior as remove, but let's look at that. Let's look at that error that I'm talking about so we can see how to avoid it. If I can purposefully write broken code, we'll see. So for L in list, if the length of L is 0, then we'll list dot remove L. Okay, well, I'm not sure why we're not getting this error. I'm not sure. Yeah, all I'm able to do is write working solutions for this, evidently, which is kind of hilarious. It's probably like just right in front of me what I'm not doing here. So sometimes, I'll just have to go through this. Sometimes when you use remove, if you're removing from the same list that you're iterating through, you can get an error that says list changed size during iteration. You can get some odd behaviors if you're removing elements from a list as you're iterating through it. That's not happening in this case, and I honestly don't know why, because this is the scenario where I'm familiar with it happening. So I'll look into that and maybe post something about it. But yeah, it is just something to watch out for. Evidently, we can get by with it in this particular case, though. So it's interesting. Okay. I did want to do a dictionary solution for this. let's see here. Real quick, let me just kind of look through here. All right, I'm not seeing another question at the moment. So I think I want to go through sort of a more dynamic solution for this involving a dictionary, and we'll see why in a second. We shall see. Okay. This code just makes me nervous, by the way. I'm just looking at this and I'm like, I'm altering the list that I'm iterating through, and it just like, it sends like warning bells off, but I'm I'm shocked that it's working. C'est la vie. Okay. Cool. So first of all, D equals empty dictionary. Empty dictionary. There we go. And then we'll say LST equals list. I still want to return LST, but for now I'm going to return D just so I can monitor it, because that's what I'm interested in building up first, and then I think we'll come to list next. So I'm going to say for arg in args, and then I'm going to add the type arg into the key, and I want to add it in as a string. I want to add it into the key of this dictionary. So I'll say d substring type arg. And I want the value to be a list. And I want to initialize the empty list again if the key is not a member of the dictionary. So that's the key, and we'll say if string type arg not in D, if it's not a key in the dictionary. And you don't need to specify dot keys here, but you can, and I actually always like to, just because it's nice, clear, explicit code, just if you want that nice reminder of whether you're checking keys or values or both. If you want to just write it explicitly, you can say d.keys. But to be clear, you don't need to, and you will usually see it this way. So I'll do it my way just because it's a little clearer, in my opinion. All right, so if the key is not in the dictionary, we add it in with an empty list, and then we'll say d sub key. I'm using this all over the place. Why don't I just do this? K equals this, and we'll just replace this with K. Okay. 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 Okay, so K equals string type arg. And if K not in D keys, D sub K equals empty list. Yeah. D sub K. Ah. Arg. I'm just gonna see what this does. Just curious. And I've kind of got these ugly ugly keys, but that's okay. Yeah. So this actually does. Initially I was thinking I would need to do type checking. But this actually sorts them without needing to do any type checking, because I'm getting the type here and appending the argument to the key according to its type, so it automatically sorts it all without type checking. Yeah, so that's kind of cool. So then I want to, from here, we can just say, we'll have our list, and we'll say for k, comma v in d dot items, list dot append v. Now this won't, I'm not sure, this won't append, this won't guarantee the order that this problem laid out as a constraint. So it might not actually pass all the tests here, but this will handle as many types as there are types of objects passed in, which is kind of interesting. So it's a variation on the theme. And I wanted to show this because I had the idea initially. I was thinking when I was first reading the problem statement, I was kind of thinking that this was what I would need to do. And then it sort of got constrained down into something else. But I thought I wanted to do this to show you, like, you know, if you have, sometimes you misread a problem as something else that's still a pretty cool problem that'd be fun solving, that'd be worth playing around with and worth solving. What I really should have done is wrote out some new constraints for myself for the dictionary, you know, so that way I can have a reference so that I can clear expectation of what I'm doing, but that's okay for this time. It's a small enough change that I personally didn't really need to do that, but yeah. Okay, so we can append the value and we'll return the list, and I still need to sort the values. We'll do that. Yeah, and unfortunately this is going to give me floats first in this particular case, so it does give it to me in the wrong order, which I think will make it fail the tests, but yeah. I just wanted to try it so I could take in any arbitrary amount of types, right? So if I add a couple other types in here, it should work. If I remember how commas work. Cool. So you can see now this has a list for strings and a list for Booleans as well. All right, cool. Just out of curiosity, pretty sure this is not going to pass the tests, but you never know. No, okay, it does. It happens to pass the test, although it's not guaranteed. Like the other solution would always come out integers first, floats second, but it would only handle integers and floats. In this case, it comes out in an arbitrary order, right? That it's going to come out in whichever type of element I think was first. So yeah, bit different, but happens to pass all the tests. Cool. All right, I'm not seeing any questions regarding those last three that we went through. Cool. Oh, you're welcome. Glad that was helpful. Thanks for saying that. All right. Do feel free. I'm sorry about the about the first question. I feel a little bad. I want to make it clear, like we're just taking Python. I'm just taking Python questions for now out of our Python material. I want to keep it constrained to that. But yeah, do feel free if you have questions about stats. Feel free to DM me, and we'll work something out and go from there. So yeah, we still got another 30 minutes before our usual stop time. So I'm not seeing any requests. So we'll just go through where we started or where we left off last time. I always think I'm going to be able to go through the material faster. I'm like, we'll start at control flow and just like blaze through this in a couple of lessons, but it's always kind of a slow kind of slog to get through all of these. So if anybody has a request about a place to start or go through material and learn, I'm open to that. Or any other questions. But for now, we'll just pick things up with where we left off with manipulating lists. I think that's right here. Okay, so mutability and modifying list values. Actually, yeah, this is a really good topic to cover. Kind of a weird... I think this is one of... I'm not going to say like it's a... I don't want to like make it sound scarier than it is, but mutability is an important concept. And there's sort of a denseness to it. I think like when you're first trying to wrap your head around mutability versus like what exactly we mean by mutability, because it's a simple idea. So mutability, the root is muta as in mutation, meaning to change. So it's just when an object has the capacity to change. So a list, if an object has the capacity to change, we call it a mutable object. We refer to it as mutable. So lists are mutable. So there's a few things that I think it's easy to look at and say, oh, well, that's mutability, but that we actually don't consider immutability, right? So let's sort of juxtapose examples of mutability versus examples of immutability. So if something's not mutable, we call it immutable. And sometimes I can talk a little fast, and I'll just kind of stutter over, and mutable and immutable will sound a little bit similar. So if I say one when you think I meant the other, please feel free to clarify that. Put something in the Slack and be like, did you mean mutable or immutable? But yeah. Cool. So yeah, let's look at some examples of both. So if I have a variable, it's easy to look to hear like, oh, mutability is just when a value changes. So if I have a variable, let's just say a equals 5, and now a equals 10. So the value of the variable a is different, but we wouldn't consider different languages think about this and deal with this differently. Some languages would say the variable changed, but the data type didn't, right? And what that means, or well, not just the data type, but the value didn't change. What that means is that we did not change 5 into 10. Like 5 is still 5 and 10 is still 10. Those are still two independent numbers. You don't change 5 into 10, at least in Python. You have 5 and you have 10, and you can point the the identifier of the variable. The identifier is the named part. It's the name portion of the variable. So I can point the identifier to 5, and then I can point the identifier to 10. Some languages will refer to this as pointer mutability, or they'll think about it essentially as the variable mutating, or the pointer, quote unquote, pointer mutating. We don't really think about that in Python in that way, at least not as much. But we would say that integers are immutable. So we're not causing a change on the data type level. We're causing a change on the variable level. So this is an example of immutability, even though the value's changing. Same thing, if I change this to a string or something else, right? So none of this is what we think of as mutability. So I just changed it to a list, and a list is a mutable type. A list is a mutable type. Sometimes that's me worrying that when I say mutable, it sounds like immutable. Okay, so here's our list. So the reason lists are immutable is that they have mutable methods. So let's look at the methods for lists. So I'm gonna print this function called dir. You've probably heard me talk about dir before. If you've been on many of my study halls, I bring it up pretty frequently because it's a really useful function. So in order to see what it gives us out, we have to print it out, and then you just pass dir any object of the type that you're curious about. It can have like anything in it, but in this case, we want to know about lists. We want the directory for lists, and this is going to show me all the methods, not the built-in functions, not the operators, but just the methods for lists. And the question is, when we look through the methods, we can ask what methods will cause a change in the value to the list itself, right? So append changes, it's a mutable method because it changes the value of the list by appending a value into it. Clear empties everything out of the list, it changes the value. Copy doesn't change the value, but it's not the only reason for copy to exist is because the value can change. If the value couldn't change, then copy wouldn't be useful, right? If the reason to use copy is because you're going to change the value to the list, but you don't want to alter the original copy, or you want to make the change to the original copy, but not the other copy, right? So it's like there may be something about the original that you don't want to alter, but you need to make the alterations to a different copy of a list. So copy doesn't cause a mutation, but it's only useful in the context of mutation. Count takes an element to return the count of. So if I have a list with like several numbers, or let's say I have a list of 10 numbers, and 3 of the numbers are the number 41. I could say list.count 41, and I'll get the number 3 back. So maybe that's a little bit confusing, but it just returns the number of elements of a given type of element that you're looking for in the list, right? So count returns a value, which is the count of some element in a list, but it doesn't change the list. So this is an immutable method. Extend is a lot like append. It allows us to, it basically allows us to append multiple items at once. Index is another immutable method. index is gonna, what does index do? Oh yeah, we pass an element, and index gives us the first index that element appears at, right? So if there's multiple instances of that element, it's just going to give us the number of the index of the first time that it appears. Insert is kind of a lot like append and extend, except it allows us to, instead of putting an element at the end, it allows us to put it anywhere else in the list. Pop changes the value of the list by removing an element. Remove, same thing. Reverse changes the list by reversing its order. And sort changes the position of the elements to be into their sorted form. So all of these literally alter the value of the list. Yeah. So that's why lists are mutable. So we can sort of further prove this. Actually, I'll leave that there. We can sort of further prove this by, let's do this. Okay. Okay. Let's look at an example. List equals empty list. Print list. There's another really useful function called ID. ID. Right? So what ID does is it tells you if two, well, it tells you the ID of an object. What it's useful for, or what I often use it for, is to see if two objects are literally the same object. So let's change the value of this list and see if its ID changes, right? So if we do list.append, hello, and let's actually we'll print the value of the list too as well. So you can see it's the same list, right? The number that we get for the ID is the same between both print lines. And we can tell if you look at the right-hand side of that ID, if it's the same, then it's the same two objects. But so the list is the same, but the value is different. So notice how the value changed, but the ID is the same. So this tells us that, you know, since it's the same object, so it has the same ID, and it changes its value, right? So that's evidence of it having mutated. Yeah. So it's kind of funny, but there are ways of adding things to lists that will change the ID, but not the value. Well, it'll change the ID and the value actually. So let's say list plus equals. So this is going to have the same behavior as append, but it's going to change the ID and the value. It no longer changes the ID. Well, that's interesting. I was certain. Okay, well, I wonder if that's updated behavior. I wonder if that's new syntactic sugar where plus equals now appends to the same list. Well, learn something new every day. Okay. So this actually does give you the same object. So this functions exactly like append, which I think is actually really good. Because I kind of like this syntax. It's straightforward and simple. We could, if we made this a tuple instead of a list, I have to concatenate with another tuple. It's weird, a single element tuple has to have a comma after the element. Kind of makes it look awkward, but okay. So this is called list, but I should, I'm going to call this tup. And then real quick, I should make two different examples here. So we'll keep list as a list. Okay, so that's our list, and then this is our tup. So let's look at the list example is going to show a mutation in the list. And you can see that this code is very similar, and it gives us very similar behavior. But if you look at the lists share the same ID, which means that it's the same list, we just changed the value. Whereas the tuple has a different ID, right? And this tells us that the tuple not only, well, the value never changed. What we did is we got a different version of that tuple, of the empty tuple, with hello concatenated into it. And then that itself was a different object, and we set that as the new value for the identifier tup. So this is a similar behavior to append, but it's actually happening on an immutable level, which is pretty cool. So why, now the question certainly is, why should you care? Let's look at an example where this kind of thing can make a real sort of tangible difference. Let's say I have a function. What should it do? Trying to think of something. Okay, I'm lazy. We're just going to call it example function. It's going to take in a list or a tuple, so I'm just going to call it sequence, because lists and tuples are both sequences of things, a sequence of objects. And then I'm going to say sequence plus equals yeah, we'll do it with a list first. Sequence dot append element. Okay. So this is for a list. So let's write a test, and I'll say list equals empty list. I'll pass my empty list into my example function, and we'll just say hello, right? So what's going to happen here is this function changed the value of list. Now this might look innocuous. This might look like it's not a big deal. It can get out of hand pretty quick when you write functions that mutate their inputs. If their inputs are mutable and your function mutates that input, it can get hard to deal with. If something is causing a change in a place where you don't expect that change to be happening, it can be really difficult to isolate why and exactly where the problem is occurring. So therefore, as a rule, when you write a function, you shouldn't do this. Specifically, you shouldn't cause a mutation on one of the parameters of the function, right? So here I'm doing sec.append, and sec is a sequence, which is a, in this case, it's a list, right? It's one of the parameters. So I shouldn't mutate one of the parameters. Now, there's times, there's times where it makes sense to do something like that, but what you'd want to do is say sec equals sec.copy. I'm getting a little ahead of myself here. So let's look at the problem first. Let's look at why this is a problem. So here I have my innocent little empty list, and I pass it to this function. The function alters it, which is no, don't do it. So this is the no, that's the nope, don't do that. So it alters its input, and then we print it out. It actually returns it too, I'm returning it. And then we print it out so we can see that indeed it was altered by having been passed to that function. So if I copy the list, now let's see what happens. Okay, so now I have my list. I pass it to the function. I copy it and then make the alteration. It's still called sec, but sec is now a copy. So I make the alteration to seek and then return seek. So that's why I'm getting the modified list returned, but the original list stays intact. It stays unmodified. So this tends to be a more desirable pattern, right? So something similar with a tuple, right? If I have, yeah, we'll just do this as a tuple. I'm still going to call it list. I'm not going to call it list. I'll call it tup. Okay. So if I have this as a tuple now, and I say sequence plus equals L then we can see it doesn't alter the original tuple, but I get the tuple out that I wanted. And in this case, I can just return that, and it's going to work just fine. All right, so this can be an example of when you're writing a function that takes in a mutable object, unless you really have thought it out and you have a really clear reason why that function really should mutate one of its inputs, don't allow the function to mutate one of its inputs. If it makes sense for that input to be a mutable object in the function, just copy it. Just have the first few lines be copies, where you're copying the parameter into a variable of the same name, or you could do a different name, but it's kind of not a reason to not use the same name. That way your function is going to behave in a safe and predictable way. So there's a lot of different paradigms and styles of coding out there. So there are times where, somebody might argue that under certain circumstances, it might be what you want to do to write a function that mutates one of its inputs. If I were doing that and I had I could justify doing that, I would probably put mutable like in the name of the function somewhere, or I would make it like clear somehow by the function name that it would alter its input. Like I would be as explicit as I could. That way, if my data starts like acting in a way that is strange to me and unpredictable to me, I can find the functions to say mutable on them and say, oh, well, this is probably the first place that I'd want to look, and they're sort of tagged already by their name. That's what I would personally do. So that's just a thought. So that's mutability and immutability in short. Cool. All right. Cool. So this is going to talk about modifying lists with indexing as well, but I'm just going to go through and do the challenges. Write a function called verify IDs. Okay. Write a function called verify IDs. This function will take two lists and will return a Boolean of whether these two lists have the same ID. Okay, so I'm not even going to bother with tests for this one because it's def. I'm going to call this L1, L2, and return ID L1 equal ID L2. So these IDs return as, I believe they just return as integers. There's not like a special type, right? So I can just see if, this ID is a number, and if it's equal to this other number, then it's a valid Boolean expression. Yeah, that's the same code. Okay, modify third element. Okay. This is something I didn't cover up there, but modify third element takes in two arguments. The first is a list, okay, and the second is the element to put in the third position of the list. So it'll be index 2. So let's say list equals, we'll say, so modify third element will modify this 6, and we'll say print takes in list, and let's just make it something conspicuous so it's easy to see on the output. Hello. Okay, and that should give me, oops, oh no. Replace this 6. Hello. Okay. Takes in list and L, and we'll say list. Okay, so what I want to do is modify this element. So I'm going to say list sub, and I'm going to specify the index that I want to alter, which is the third element is index 2 equals L. So this is a mutation, to be clear. So this returns none, but if I print list, I'm pretty sure that this is, I know I just told you not to do this, and I stand by that, but I'm pretty sure this question in learn is asking you to do this, to modify one of the inputs. We'll see though. I could be wrong. I want to kind of go through and oh, hey, hello. It wants us to remove, or it wants us to return the list as well. Oh. Oh, hello. Okay, so I was wrong. This does not want you to alter the original. Good. List equals list dot copy. I'm just being silly. I mean, I know the people who wrote these. I trust their coding. Like everybody on my team is a good coder, so I should know. Like they're not just gonna throw that in there. But okay, good. So this question, we do need to copy the list before we alter it, right? So in this case, I'm copying right away. I don't need access to the original list, so I'm just going to override that identifier with the copy of it. That way I can't even alter the original. Then I'll alter the copy and return the copy. No, we already tested it in the past. Okay, good. Write a function called replace at index. I think this is the same thing. Yeah, but it'll just take in a given index. You know what? Just going to copy this. And this will be called replace at index. And it'll be list, index, and object. So list, IDX. Oh, I don't know why I did that. Okay. Will that do it? I think that'll do it. That'll do it. Okay, so all I did was change the name, add this index parameter at the appropriate place. Notice it says list, then index, then object. So the order is going to matter for the tests. It's got to be in that order. And then I'll say list equals list copy. I'll make the copy, make the modification. And instead of changing the element at index 2, I'm just changing it at whatever the IDX parameter was. Setting that equal to element and then returning the list. So that's all I did. Awesome, cool. That puts us about at time. Yeah, this was a lot of fun for me as usual. I do enjoy this. Apologies for the, again, not taking the stats questions at the moment. But yeah, we can work on those offline as well. I am available for meeting for one-on-one mentorship if anybody wants that. So just DM me on Slack. Yeah, just DM me on Slack, and sometimes it can take me a little bit to get back to people if I'm busy with other stuff, but I do have a lot of availability for meeting in my calendar for the next foreseeable few weeks. So things are slow with interviews at this time of the class cycle, so I've got plenty of time. Yeah, don't be a stranger. Have fun interacting with all of you. I appreciate the questions and the interactions. I see people like helping each other out in the Slack thread, which is awesome. Yeah, truly my pleasure. Look forward to next time. And if you're in Premium Prep, you'll be working with Tovio this week, and I'll see you in Premium Prep on Saturday. Go ahead and give us a like, comment, and subscribe on YouTube if you feel like it, or maybe if you hated the video, you can give us a thumbs down too. I guess that's that's fine. It's your prerogative. Do as you will. Do feel free to share any feedback with me about the videos. If you have ideas about how to improve this, I'm all ears. Won't promise that I'll implement those necessarily, but yeah, we would love to hear your constructive feedback. So yeah, I will see you Wednesday for next study hall. Cool. Bye bye.